We're going to take a look at graphing inequalities with two variables. Remember, the word inequality means you're going to have some version of a less than or a greater than or a less than or equal to or greater than or equal to sign. When we're working with an equation, we have an equal sign. We'll be working with these. So here's an example of an equation that we've graphed with y equals mx plus b form, and right next to it is an inequality that's been graphed with y equals mx plus b form. You'll notice there's nothing different yet. We're going to change something here in a moment, but you do have a greater than or equal to sign instead of an equal sign, but I still have my same y-intercept and my same slope down 2/3. So what's different? When you graph a question like this, after drawing the line, you take a look at the inequality sign, and that inequality sign says greater than or equal to, and that means you're going to shade greater than or above the line that you graphed. There's no shading over here because it's an equal sign, but because that says greater than or equal to, we've shaded above. Now this shaded region that we have, that's called also the solution region, but some people call it the shaded region. They're interchangeable. And so I'm just going to put a point into that solution region or that shaded region. It's the point 3, 5. Okay. There's the point 3, 5. And because it's in the shaded region or the solution region, I know x equals 3, y equals 5 is a solution to that inequality. In fact, any point in the shaded region makes that inequality true. Any point not in the shaded region makes that inequality false. I'll show you. The point 3, 5 that I was just talking about was in that shaded region. If I take the x equals 3 and the y equals 5 and plug it into the inequality that we were given, eventually I work it down to a true statement. And remember, when you do something like that to check your work in math, if you get a true statement, you know that you have a solution. I'm going to also work with the point xy 3, 1, and I'll show you where that is on the graph. 3, 1 is right here, and that is on the other side of the line. That's not in the shaded region, so that should give us a false reading when we go ahead and plug that into the inequality. So I take the x and the y, and I plug in the x, I plug in the y, and I work out the math, and I eventually end up with a false statement. But I should have known that was going to be a false statement or not a solution just by looking at the graph and knowing that my point that I was investigating was not in the shaded region. A couple of details remain. I've taken two inequalities that look almost the same. The only difference is this has a less than or equal to sign, and this just has a less than sign. So when you have a less than or equal to sign, you will use a solid line, and one of these uses a dotted line. So that's just something you need to memorize, but here's what that means. If I took a point that was right on the border, it is included or equal into that solution region. In a case like this, if I put a point that was right on the border, that is not a solution. So that's what the dotted versus solid line means, but you just need to remember that if you have an equal sign under your inequality, solid line, no equal sign under there, dotted line. Hey, if you like things repeated, no equal sign underneath the inequality, better use a dotted line. Equal sign underneath the inequality, better use a solid line. I'm going to run you through this one last example that might be a little deceptive. I have a greater than sign, so I'm going to be shading above my graph. There's no equal sign underneath there, so I use the dotted line. My slope, by the way, is 5/1 because anytime my slope is an integer, I can write it as a fraction. So when I graph this, I started with my y-intercept of 5, and I counted up 5, right 1, or -5, left 1. They're both going to put you on the same pattern, down 5, left 1. But the reason I showed you this example is sometimes you lose a little bit of confidence on shading above or below. This is a greater than sign, so I should be shading above this. This line is almost vertical, but if I look at the slight diagonal of it, above it would be shaded like that. So if you're ever confused on it, just pick a spot on your graph, even if the graph looks almost like a vertical line, and just shade above each individual spot if it's a greater than sign, or below each individual spot if it's a less than sign. Remember the true meaning of what you're doing. Any point you pick from the shaded region is a solution to that inequality, meaning the x and the y make that true. Any point outside the shaded region is not a solution to the inequality, meaning that x and y make that inequality false.